The second longer term project we're working on at the moment is a sensor unit for temperature and air quality in a home environment. We originally decided to do this to track the loft space and to see if it maintained a comfortable enough temperature and humidity over the winter, and if it does, we'd end up moving the workshop up into the loft.
There are two ways to track this data. One is to measure a few times over a week and see if it feels warm enough, and the other one is to spend months working on a project that measures this automatically and takes weeks to tell you the thing that you could have worked out in moments.
And obviously we chose to do the latter of those two things and spend months working on a project that we could have worked out if we'd just gone up into the loft.
We want to start with this project fairly simply by just checking the temperature at an hourly interval and build that into a graph over the winter and then summer months to see if it's a comfortable work environment.
When we were looking at sensors, we found the DHT11, and we had one of these in our sort of box of bits, so we decided to start with that, which is the little blue thing on this board. Turns out it also records humidity, so we expanded the scope to include humidity as well because it was no extra work at all, and expanding the scope of a project like that is a dangerous habit to get into.
We're using a DHT11 and an ESP32 board to log the temperature and humidity and change our sampling rate from every hour down to every half an hour and then down to every 15 minutes. Because we were getting quite impatient whilst waiting for each data point.
So whilst this started fairly simply, we quickly realised that there are loads of other data points that we can collect in the same way. We can monitor for carbon monoxide, we could check carbon dioxide levels, we could look for volatile organic compounds, detect gas, all sorts of other fairly useless things. Whilst all of this sounds interesting from a home automation perspective and having the potential for turning on heating or dehumidifiers or ventilation based on sort of log data, for now we still need to get the thing up and running and recording data points.
In the Gantry robot project we're using an Arduino for controls, but in this we're going to be using ESP32 because it has built-in Wi-Fi capabilities and they're just generally cheaper boards.
For now we're just going to get the DHT11 up and running and recording data points regularly, and at this stage we'll just have them printing to the terminal so that we can make sure all of the wiring is correct. Then we can look at wrapping some of this code up into neat functions and building a whole system around it. As is likely to be the case, it will either be me talking about Ethan's code or Ethan talking about Ethan's code, so we'll see where that one goes.
So this is the code that we came up with. Following on from the code that we had in the DHT11 introduction video, we're just importing from machine, pin, and now timer, importing from the DHT library, and also we're importing a local time. It's the same pins configured in the previous video. We configure the DHT onto the data pin. However, now we're getting the local time. This function spits out the year, month, day, and a bunch of other things. We're only going to be using hour, minutes, and seconds. We measure data as normal. We get the two parameters that we want, and then we're just printing it to the terminal of hour, minute, seconds, and then the temperature and humidity. We're just writing it to a file, a text file. So we open it in append mode, we write it, and there's \n. It's just so each line of the text file is a data point, because otherwise it would all be in one line and it will just be really difficult to read. And then we just close the file. And so here we're just using a timer on the ESP32. The period, timer.periodic, just means that it will trigger in certain intervals, and the period being 5000 means that the intervals are 5 seconds or 5000 milliseconds. And then the callback is just which function does this timer want to call. Measure sensor, which just has the timer as a parameter. And so if I run this, we can see that every 5 seconds it will run this code, which here we go, is 12:59, 35 seconds, and at 16 degrees, 64% humidity. This will be increased up to an hour, 30 minutes, 15 minutes, depending on what we need. But for now, just to show that it works, we've put it on 5 seconds because I don't think we'd want to wait 15 minutes just to see the next data point. And so this should be plenty. Just ignore this error. So now, if we go open IcoPython device and we open the text file that's on it, we can now see all of our data. So this is our first one, and in intervals of 5 seconds.
So I realised when I was editing this that we didn't actually record an outro to this video, so just to have a few notes here. I know this has been really basic so far. We've already started working on the next sections, and the next sections are getting more interesting. We've got, you might be able to see in the background here, this is our server console now. We've moved the server from the PC to the Raspberry Pi, and we're going to run that basically 24/7 just with the monitor off to record data points, and we should have something to show you on that in like a week or two, probably a fortnight. For now, this is like the basics. We're building this from scratch. We're learning as we go. Please excuse us if it's a bit too basic. It will get more interesting and it will get more complex as time goes on. And we have more complex projects coming up as well that we're trying to get the basics established before we start trying to take on anything too much. It's always been a trait of mine throughout my life to take on too much and then subsequently not be able to finish it. So I hope this has been at least somewhat useful, and we'll look forward to chatting to you soon.